Hello everyone. In this video, I'm going to go over how to generate a basic car body CAD, which you're going to have to do as part of the 4231 and 5230 final project. This tutorial is intended to be a basic demonstration of how you might go about generating the CAD model of the car body in Fusion 360. You're more than welcome to use other techniques to generate your model or other CAD packages if you're more familiar with them. So let's get started. To start, I'm going to create a new sketch on the XY plane. And I'm going to define the wheelbase length. So according to the problem statement, we're going to start off with a wheelbase length of 3 inches. So I'm going to draw a horizontal line and hit escape, and then dimension it with the D key. Brings up the dimension tool, and then click on the line and dimension it to 3 meters. Before we go any further, actually, I want to make sure that we are using the correct unit system. So the way we can do that is go to the profile button on the upper right and click preferences. And then you should be able to go under default units for design, and you have to make sure that it says meters. If this doesn't say meters, then you might have started generating your sketch in a different unit system. So change this to meters and close out of the system and open it up again, and you should be in the metric system. Okay. So now that we have the wheelbase line defined, we can constrain it to our sketch. So we're going to constrain the midpoint of that line to the origin and make it a construction geometry, because this is not part of our actual vehicle. So the way we make it a construction geometry is we click on the line and then hit the X key, and you can see that it's become dashed, and that means that it's construction geometry and it's just used for reference. Now, we need our vehicle to sit on some sort of pedestal, which is going to be used to generate the enclosure. We can't have the car terminate in a circular wheel because Space Claim doesn't let us generate an enclosure around the vehicle if we have the bottom of it terminate in a wheel shape. So we need to basically sit the car on top of like a pedestal. And the way that we do that is we just generate 2 rectangular structures where the wheels would go, and we have the vehicle sit on them. So we're going to do that right now. So to do that, we're going to get the rectangle tool, and we're going to make a rectangle that is about 0.25 meters in width and about 0.05 meters in height. And then we're going to constrain this rectangle to the corresponding points on the wheelbase. So first let me copy this. So we copy this by selecting it, Control C, and then Control V. And then we can drag this out, and we have a copy of the rectangle. And then we constrain the midpoint of each bottom of the rectangle to the endpoint of the line that defines our wheelbase. And then you can see that that's fully constrained. Okay. So now that we have these pedestal structures in, we can add our wheels. So we're going to create 2 circles, and we will dimension them to a diameter of about 0.45 meters. And then we have to constrain them to sit on these pedestals. So what I'm going to do here is I'm going to create a vertical constraint between the middle of the wheel and the middle of the pedestal. And we do that with the horizontal vertical constraint tool. So that one didn't work, so let's Control Z a couple times and move this over. Oops. Kind of in the right place, and then we can do the constraint. And Fusion should automatically detect that we want to do a vertical constraint there. So that's great, and then we want to define a tangent constraint between the circle and the bottom of our pedestal. So we're going to define one right there, and another tangent constraint right there. And so what this effectively does is it smushes the wheel. So you can see that we're going to be importing the outer profile of the wheel, and then over here at this intersection, it's just going to, Fluent and SpaceClaim are going to see the bottom portion of this. And then it's going to come down kind of at right angles, and then it's going to come back up, and then keep going with the wheel profile. This small error is going to be okay for our purposes, and you can see that the Ahmed car body example that we went over in class did something very similar to this. So okay. Now we're going to define the floor of the vehicle. So that's pretty simple. All we need is this horizontal line. And we need to define a height off the ground. So the x-axis in this case is the ground, and you can see that it contacts, this is where the wheels will actually contact the ground reference frame. But we need a height for the bottom of the vehicle, from the bottom of the vehicle to the ground. So we're going to define that right now. So dimension the height from this line to the origin, and let's make it, let's say 0.15 meters, and that looks just about right. So okay, so now we have kind of like the basic shape of the car coming about here. We have two wheels in the bottom. Now we need to generate the actual enclosure of the vehicle, or the rest of the frame. So to do that, I'm going to create two lines going one behind the car, one in front of the car. And let's not worry so much about the lengths yet. What I want to do is I want to constrain them so that they are in line with the bottom of the vehicle. So what I'm going to do is I'm going to go for the horizontal vertical constraint, and I'm going to constrain the endpoint that's touching the wheel to the endpoint of the bottom of the vehicle that we just defined previously. So create that constraint, and then we're going to create the other constraint on the other side. There we go. Now you can still adjust the lengths of this. So this is where you're going to adjust the final length of the vehicle. Now, in the problem statement, we said that we recommend a vehicle length somewhere between 3 and 8 meters. For the purposes of this example, I'm going to try to aim for a vehicle length of 5 meters. So since I've done this before, I kind of already know the predetermined position of where these lines should be in order to hit my target length. But you guys, if you want to change your length around a little bit, you might have to do this from scratch and try to make sure that your vehicle hits the length targets that we're going to hit, or that you're required to hit. Sorry. So this is going to sound a little bit arbitrary, but for now, I'm just going to say that we're going to dimension this line, the front line of the vehicle, to be 0.6 meters. And we're going to dimension the back line of the vehicle to be 0.5 meters. So it's going to be a little bit longer in the front than it's going to be in the back, which is fine. And what I want to do here is I want to create a reference line, a vertical line, which is going to tell me when I hit my half-meter mark or when I hit my 5-meter mark for the length of the vehicle. So I'm going to make a construction geometry over here, and I'm going to constrain it to this point that I just made. And so you can see here we can have the total length of the vehicle here, and I'm going to make this 5 meters. And there we go. So now, so long as the back face of the car lies on this line over here, a line that is vertical to the rightmost point, then our vehicle will be 5 meters long. So now we're going to define the curvature of the upper part of the car, and to do that, we're going to use the spline tool in Fusion. So in order to use the spline tool, we need to create a fixed number of points that we can use to draw a spline around. So what I'm going to do is I'm going to create 8 points around the domain here, and we're going to use those points to determine to define the spline. That's going to define the curvature of our vehicle and its outer frame, the outer body. So what I'm going to do is I'm going to define 8 points, so 1 here-ish, 1 here-ish, here, 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 and that's 1, 2, 3, 4, 5, 6, 7, 8 points right there. Or 7 points. Sorry, we don't need 8 points. Let's do 7 points for now. Now, these points are just kind of floating in free space right now. We can move them around, and that's not exactly what we want. We want to kind of constrain them so that we define the curve of the vehicle properly. So what I'm going to do is I'm going to start constraining them individually. So this point is going to be the forwardmost point of our vehicle, so I'm going to have it be coincident with this line that we defined earlier. And I'm going to give it a height of around, I'm going to give it a height of around 0.25 meters from the bottom of the vehicle. And then I'm going to define this point over here to be another 0.3 meters above that point. Then I'm going to do another 0.3 meters for that point. And I'm going to do a 0.4 meter dimension from our reference 5 meter line. So, and then the final dimension here, 0.9 meters for this point over here. So now you can see that these lines have turned black, and that means that they're fully constrained in the 2D space, and we can draw a spline around them. So we're going to go to the Fit Point Spline tool and create a spline in between these points. And there you go. That is the front curvature, the frontal curvature of the body of the car. And now we're going to move on to do the passenger area and then the trunk. So for the passenger area, I'm going to constrain this point to be 0.75 meters from that previous point and 0.35 meters in height away from that point. And now this point over here, we need to be careful of, because this point cannot be any higher than 1.5 meters because of the constraints that we set in the problem statement. So we want to make sure that this point doesn't cross the 1.5 line, which is this line over here. If you want to get a little bit of a better visual for it, we can just draw a horizontal line, set it to construction geometry, and then dimension it off of the bottom. And we can set it to 1.5 meters. And we have to make sure that our point here doesn't go any farther than 1.5. Or doesn't go any farther above 1.5. This point is also going to define the maximum height of our vehicle. So we want to make sure that we place it in kind of a good location. So since our car is a little bit tipped forward here, like the dimensions, it's longer in the front, I'm going to move this point a little bit farther back along the x-axis. So let's dimension it. We're going to dimension it relative to the origin this time. And we're going to dimension it to 0.25 meters behind the x-axis. And since we want to keep our height at 1.5, let's just keep the point on the line. And that point should be fully defined right there. So that's perfect. And then from that point, we can define this point. So let's do another dimensioning operation here. And let's say we're going to do 0.85 meters and 0.2 meters. There we go. And then this final point here, we can do a horizontal constraint with this point over here to define the position on the y-axis. And then for position on the x-axis, we're going to say that we want this to be about 0.25 meters behind the center point of the wheel. So there we go. Now we've defined our points for the passenger area, and we'll create a spline that joins all of them. Once we've connected all the points, click the green check mark, and there we go. We have the spline defined. Now for the back section here, it's going to be pretty simple. Let's just create a straight line, use the regular line tool at this point, and we're going to go over, or sorry, let me probably begin down here. It'll be a little bit easier. We're going to go up and then over, and we want to make these corners rounded, so we use the fillet tool. So let's do a fillet down there for 0.3 meters. It comes up with a warning because it's mad that I basically ruined the constraint by adding a curvature there, this 5 meter constraint, but it compensates for that by adding a point there, so we should still be fine. And then do another fillet up here with 0.2 meter, and there we go. That is our generic car body shape right there. And if we finish the sketch and look at this, we can verify that the total length from the back to the front is in fact 5 meters, and that the total height from this point down here is 1.5 meters. And you can kind of see, oh, so the spline actually crosses that line, which is not ideal, but we can go in and fix that. So let's go in and fix that. We can do edit sketch, and then the way that we fix that is we click on the spline and make sure that this green line that crosses through this point is horizontal to that reference line that we drew at 1.5 meters. And that makes sure that the maximum or the highest point of the vehicle is located right at that point. And we hit finish sketch, and there we go. That looks a lot better. Okay, so now all we have to do is extrude this into a 3-dimensional shape. So we'll go ahead and do that right now. So we go to extrude, select all of these faces, and we're going to pull it back this way about 0.175 meters. Oops. Oh, sorry, negative 0.175 meters. Okay. And there we go. We extracted it 0.175 meters because that will be the width of the tires or the wheels for the purposes of this demonstration. If you guys want to use a different width, feel free. And then we have to extract or extrude the rest of the car body without the wheels. So the way that we do that is we need to create another sketch on the back face of the vehicle this time. And we'll hit the P key on the keyboard and project the geometry of the car onto this sketch plane. So you can see that I just projected the geometry and the lines are all purple, which is good. And then we'll close off the portion, the bottom portion of the wheels because we don't want to extrude that. So we'll just get the line tool and join or close off the wheels from the rest of the model. Hit finish sketch, hit extrude, hit the upper section, and then you can see we can just pull the rest of the car whatever distance we want. And for this example, I'm going to pull it 0.7375 meters. And there you go. So that is one half of our car, and then if you mirror this on the other half, on the other side, you'll get the other half. Now, for the final step, what I'm going to do here is I'm going to fillet the corners, or the outer corners of the vehicle, so that they're not, so that the surfaces are not at like right angles to each other. So let's go to the fillet tool, and then we can just click along the outer profile of the car, minus the wheels, because we don't really want the wheels to be curvy. And let's give it a 0.125 maybe meter curvature, and there you go. So now you can see that this looks like a pretty good representation of the average sedan. Wheels do look a little bit small. Maybe we might want to increase the size of them, but for a, I guess, quick and easy model that you can all use to baseline your Fluent results on, this is adequate.